All right, guys, this is a lesson on 4.1, which is area of parallelograms. Make sure you guys write down tonight's homework in your planner. On the back of the notes that the substitute gave you, go ahead and take a quick second, pause the video once I'm done talking here, and just see if you can draw out these shapes on the blank back page of your note there. So a square, a rectangle, a parallelogram, a triangle, and a trapezoid. Let's just see what you remember. I'll stop talking for a few seconds here so you have some time to pause. All right, hopefully you're back and you've tried drawing those shapes. I'm going to freehand draw these, so they're obviously not going to be perfect. But what we know about a square is that it has 4 equal sides. Now, we use these things called tick marks in geometry. We're basically doing a unit on geometry right now. Geometry deals with shapes. We're doing 2D shapes right now. So these little marks that I just put on the sides, since they're all the same, they're all just one little tick mark, that indicates that those sides are all the same or congruent. That's one thing we know about a square. It has 4 equal sides, all right? Hopefully another thing you know about squares is their angles are all the same as well, and they're a special type of angle. We use this little symbol that I'm drawing inside the angles to indicate this type of angle. It has 4 right angles. And hopefully you're thinking to yourself that a right angle is how many degrees? 90 degrees, okay? So 4 equal sides, 4 right angles. A rectangle, a little bit different. The main difference is instead of having 4 equal sides, it has 2 sets of congruent sides. So you can see the tick marks are a little different here. These 2 sides both have 1 tick mark to indicate that they are the same length. These 2 sides both have 2 tick marks to indicate that they're the same length, but not the same length as the one with the 1 tick mark. Rectangles also have 90-degree angles. So they have 2 sets of equal sides, and then the 4 right angles. Parallelogram. Kind of a tricky one to draw, even for myself. That's probably the best way to draw something that's strictly a parallelogram. So a parallelogram, much like a rectangle, has 2 sets of congruent sides. Now mine kind of looks like these 4 could all be the same, and that would be okay too. That could still be a parallelogram. But we know for sure that the 2 across from each other will be congruent, will be the same size, or length I should say. So 2 sets of equal sides. But take a look at the angles. Those are not 90-degree angles. These ones, see how I'm putting a little curve mark on it? 90-degree angles always have the perfectly straight lines, kind of makes it look like a square in the corner there. These curved tick marks are showing that those 2 angles are the same size. And then these, now I'm going to put 2 of the curves to show that these 2 are the same size, but not the same as these. So it is 2 sets of equal sides and 2 sets of equal angles, but they are not 90 degrees. And the other key thing, it's called a parallelogram. It has parallel sides, which if we look back at the other shapes we've looked at so far, they do too. If you guys don't remember what parallel means, it means 2 lines that are the same distance apart and that will never meet. They will never intersect. And that's actually the symbol for parallel, is 2 parallel vertical lines like that. So this has 2 sets of parallel lines. This line and this line will never meet. This line and this line will never meet. They're parallel. Well, so does a rectangle. So rectangle technically is also a type of parallelogram. It's just a specific type of parallelogram that has 2 sets of congruent sides and 4 right angles. A square is also a type of parallelogram. It's just a special type of parallelogram that has 4 equal sides. So really these are all parallelograms, but the only name you can give to this shape is parallelogram because it doesn't meet the criteria of a square or rectangle. So that's why we need that separate name. Triangle, easy, but there's a lot of different ways to draw a triangle. Maybe you drew a triangle that looks something like this. Maybe you drew a triangle that looks like that. Maybe you drew a triangle like that. There's lots of different types of triangles. This is a right triangle because it has a right angle in it. You might remember learning that name from last year. This one I tried to draw so that all three sides are the same length. I'm not sure I accomplished it exactly, but close enough, okay? That would be called an equilateral triangle. You can also classify triangles by their angles like I did here. This would be an acute triangle because all those angles are acute. Think acute, little, less than 90 degrees. This one I classified by its angles as right. We don't really know the measurement of the sides here, but let's pretend like I do know the measurements. See how I put different marks on every side? That means all the sides are different. Don't know if you guys remember, but that's called a scalene triangle, when all the sides have different measurements. Here I was trying to show an obtuse triangle, so an angle where it's more than 90 degrees. Think like obtuse, obese, right? Big. And then you can also have, we talked about all the three types of angle classifications. We have equilateral, all three sides are the same. Scalene, none of the sides are the same. You can also have an isosceles triangle, where two of the sides are the same. All right, I'm going to erase a little bit of that there so I have some room for my trapezoid. Trapezoid's our last shape. Trapezoids can look different ways as well. That's one example of a trapezoid. But I also could have something like this. The trapezoid, and in math we can use tick marks that kind of look like I'm drawing an arrow on the side there to show parallelism. So that's showing that these two sides are parallel. These two clearly are not. If I were to continue that side and continue that side, they would eventually intersect, so definitely not parallel. But these sides are. If I continued them on, they would never intersect. So a trapezoid has one set of parallel sides, whereas all those other shapes up there have two sets of parallel sides. Not the triangle, but the ones above, right? All the ones up here have two sets of parallel sides. Trapezoids can have congruent sides, but it's not necessary. So I've drawn this one to have congruent sides here and here. But in this trapezoid, none of the sides appear to be the same length. But again, we have the two parallel sides, and this would be called a right trapezoid because it has a right angle in it. Basically, this is a preview of Chapter 4. Today, we'll focus on the top three shapes up here because they're all parallelograms, and hopefully you notice that the name of today's lesson is area of parallelogram. So basically, we'll focus on finding the area of a square, a rectangle, and a parallelogram. Triangles and trapezoids will come up later in Chapter 4. So now let's look at your official notes here. You guys will be able to derive and find the area of a parallelogram. Make sure you jot down this definition. A parallelogram is a four-sided 2D shape with opposite sides parallel. So keys there. All parallelograms have four sides, no more, no less. They're 2D, which means they're flat. There's no height dimension to it. Their opposite sides are parallel. Those are the only things that have to be true about parallelograms. Then there's like rectangles, which are a certain type of parallelograms, which can have two sets of congruent sides, and squares, which are a special type of parallelogram, which have four congruent sides. So, I have here, I think we can all agree that this is a rectangle. I see these two sides look to be the same length, these two sides look to be the same length, this looks to be right angles in here. Okay? Hopefully you guys remember from last year that the way you find the area of a rectangle is you can do length times width, or sometimes we refer to it as base times height. We're going to refer to it as base times height in this class, okay? But length times width means the same thing. Base would be my bottom measurement here. Height, hopefully, makes sense to you, right? Here would be my height on the side. So I would do the base times the height to get my area of my rectangle. Now, this shape here, we can agree, same size as the rectangle above here. There's just this little line through it, but otherwise the exact same size, so I would think I could do base times height to find the area of this rectangle. Base times height. But what if I take this piece and move it over here? What shape did that just become? Hopefully you're thinking to yourself that that now kind of looks like the parallelogram that Mrs. Gillespie drew. And maybe like the parallelogram you drew on your own. Well, a parallelogram's area is still going to be base times height. But where'd the height go? Let's rewind for a second here. Not actually on your video, but let me put this back. The height goes with this line right here. Well, where's that when I move this over? Right there. This is not the height. Why not? Well, because now that's slanted. Think about if you went to the doctor and they said, okay, we're going to measure your height now. You wouldn't stand slanted like this. You would stand up nice and straight, right? You stand with your back up against the wall and as straight as you can because you want to be as tall as you can. A slant cannot be a height of our shape, of our parallelogram. But think about that line that we were identifying as height is now right here. It's in the middle of our shape. Well, that's okay because we have to have a height that makes a 90-degree angle with the base. It has to be standing straight up and down. So just think about measuring your own height at the doctor. You would be standing up straight, not leaning like this. So that's a really important point that we need to write down, is that the height must always form a 90-degree angle with the base. So make sure you write that down. Pause it if you need to. This I kind of said already. So if a parallelogram is the same as a rectangle, then the formula is the same. Area equals b right next to h. Remember we've talked about now that we're working with algebraic expressions, a number next to a variable means multiplying, a variable next to a variable means multiplying. So this means the same thing as if I were to write it as b and then a little times sign and h. Remember we don't want to use an x because that's going to look like a variable. Okay, so multiplying base times height gives you the area of your parallelogram. And we've talked about this now that we looked at that example there. Height's always a straight line from top to bottom. It always forms a 90-degree angle, a right angle. So in these parallelograms, you would have to draw in a height. Now you won't have to draw in a height yourself today, but you'll have to make sure that you're looking at the appropriate measurement when they give it to you in your book. They typically, if it's a line drawn within the shape, draw it dotted to show that it's not actually an outside measurement. And then they'll usually show you this as well, that it's making a 90-degree angle so that you know for sure that it's a right angle. So that's your height. They could draw it here. Sometimes they draw it outside of the shape. So they'd have dotted lines here and here. And then they'd give you the measurement right here. That's still the height. It still would go over to the same height as the top of my shape. They could draw it right in the middle. So long as it goes from top to bottom in a straight line, it makes a 90-degree angle with the base. Over here, it could look something like this. Again, it could be outside your shape. But that's what your height has to be, a straight line. It cannot be these slanted cells. Okay, those are not the height. So let's take a look at an example. Find the area. We'll get to that in a second. So we know our area formula is base times height. But they gave us 3 numbers here. They do that sometimes in math. Sometimes we have more numbers than we know what to do with, or we have more numbers than we actually need to solve the problem. And that's the case here. So we need to figure out between the 6, the 7, and the 8, which are the 2 that we need. So, in other words, which 2 are making the 90-degree angle? Well, I see drawn in line here, and I see that 90-degree angle. See how this symbol touches 2 sides of my shape? Or not 2 sides, but 2 of the dimensions of my shape. It touches this line right here that I'm making a dot on, and it touches this dotted line right here. The 2 lines that it touches are the 2 lines that are making the 90-degree angle. Those are the 2 dimensions that are your base and your height. So that is a way to tell if you're not sure. These are the 2 lines making the 90-degree angle. So this line is this measurement. This is your base. This line is this measurement. This is your height. So our area would be 8 for the base times 6 for the height. We get 48. And I asked, what's the units? You know I love to make sure you guys label things, okay? Well, when I did 8 times 6, technically I was doing 8 centimeters times 6 centimeters. So I have 48, and then I had centimeters times itself twice. Well, something times itself twice is the same as to the power of 2, right? So your official answer with units is 48 centimeters squared. All area problems is whatever units they use to measure the sides in, squared. So if these were inches here, my answer would be 48 inches squared. If these were miles, my answer would be 48 miles squared. If it was feet, it would be 48 feet squared. Let's look at an example where it's drawn on a grid. This means they gave you no dimensions, you're going to count them up. You also are going to have to figure out the height yourself. So I kind of lied, I said you weren't going to have to figure out the height, but I forgot about these problems. My bad. So your base is your bottom. How long is that base? Draw a little circle, a little dot, at each point where the line begins and ends. Look beneath it. Don't worry about this part up here. What I do sometimes is I hide it from kids. So I'm going to only show you, and you can do this with like a piece of paper, just enough so you're not seeing the rest of the shape. How many squares long is this line that I have now put dots on the end? Well, I see one square right here and one square right here. So it is 2 units long. But sometimes looking at the rest of the shape, students want to look like all the way over here and count that as the length, but it's not. It's just how long that line is, and that's 2 squares long, all right? Now the height, remember, has to make a 90-degree angle at the base. So I can't really draw it inside the shape. No matter where I go, it's going to be outside the shape. So I'm just going to start from all the way over here. I know that would eventually touch the top. So that's a straight line that makes a 90-degree angle with the base. How long is that line? Well, whoops. Let's see if we can do the revealer the other way. There we go. If you're not sure, just look at the line. Again, you can put like a little dot on the end if that's helpful to show you where it starts and stops. I see 1, 2, 3, 4, 5 boxes that line up against that line. So this is 5 units long. So this is my base. This is my height. I now have enough information to find my area. Base times height is 5 times 2, which is 10. We don't know how big these squares are, so when you're asked to find the area of a shape that's just on a grid like this, you just use the word units. You still need to say squared though, because it was 2 units times 5 units. Over here, that's just the same information with just the numbers pulled in, so the 2 and the 5. Oops, let's get rid of that. All right, example 3, find the area. So take a minute, see if you can figure out by yourselves what's the base and what's the height. So remember, our area is going to be base times height. Hopefully you've decided that 13 and 5/10 is your base, and that's making a 90-degree angle. If this is 13.5, the one across from it's also 13.5, right? So it's making a 90-degree angle with this side. So that means the 19 is your height. So I want to do 13.5 times 19. Well, think back to chapter 2 in decimals. The trick with decimals is pretend like there aren't any. Multiply them like they're normal numbers. And then at the end, put in your answer. I'm going to cheat here since this is a video and I'm trying not to make it 1,000 minutes long. And I'm going to use my calculator, but you pause and try to do this on your own. All right, hopefully you're back and you've tried to do this yourself. After doing your math, hopefully you forgot these numbers, and you should have one number behind the decimal. So remember, move back 1. So 121.5, or 121 and 5/10, and your units would be meters squared. Let's look at one with fractions, also chapter 2 reminder, right? So take a minute and figure out what's your base and what's your height. Hopefully you looked for the right angle and decided, well, right angle is being made by this side and this side, so that one's clearly 2.5, that's our height. This one would be the same length as that one, so the 5 3/4 is my base. So you want to do 5 3/4 times 2.5. Remember, with multiplying, you must make those mixed numbers in improper fractions. You can't just do 5 times 2 and 3/4 times 1/2. That won't work out. So make it improper. 5 times 4 is 20, plus 3 is 23, over 4. 2 times 2 is 4, plus 1 is 5. I don't see any cross-reducing opportunities there, so we'll just need to multiply straight across. So 23 times 5 is 115. 4 times 2 is 8. You're welcome to leave your answer like that, but if you don't want to, that would give you 14 3/8. Our units, whether you leave it as an improper fraction or make it a mixed number, would be centimeters squared. Either of those answers is fine. Similar idea here, just kind of turned around a little bit. Take a minute to figure out what your base and height are. Hopefully you decided that it's 20.5. You can see that's my height right here. And that's touching these two lines, so those are my parallel bases, so 30 is my base. So you would do 20.5 times 30, although you can get rid of the decimal and think about it later. When you multiply that out, you should get 6150. You had one decimal in here, so that means you need to move it one back. So you'd have 615 yards squared. All right, I think this is your last example on your notes here. Find the area of the shaded region. Hopefully this copied well enough for you to be able to tell which one is shaded, but at least on the video here it should be pretty clear to you guys. So I have a orangey yellow parallelogram here, and inside of it is like a rectangular piece has been cut out. So the shaded area means everything, but not this white part, because that white part's not shaded in. So take a minute and think about what your strategy might be for solving this problem of finding just the area of the shaded region. I'm going to give you a second so you can pause and think about it without me telling you right away. Okay, so the area of the shaded region. Well, I have this big orange parallelogram. I know that the area of the parallelogram is base times height. I'm going to say parallelo, okay? I know I need to do base times height. Well, what's the base and height of my parallelogram? Well, I see my 90-degree angle here. I can tell that 5 is this length, and then 7 is my base. So I'd want to do 7 times 5. So that entire orangey shape is 35 feet squared. But I can't include this white part. That white part's not shaded in. So it must be less than 35 because I need to take this away. So I'm going to want to subtract the area of the rectangle, which a rectangle is also a parallelogram, right? So the area of the rectangle would also be base times height. Well, that's easy to tell the base and height of a rectangle because they already make a 90-degree angle. So it's going to be 1 times 3, which is 3. So 35 feet squared minus 3 feet squared means the area of my shaded region is 32 feet squared. Hopefully that was a good lesson for you on area of parallelograms. You can stop the video and start working on your homework.